Hi, my name is Teresa Ruffin, and I'll be talking about water purification using chemical engineering techniques. So, a little bit of background because the Earth's water is mainly salt water and there's a limited amount of fresh water, we must reuse the fresh water that we do have in order to match the world's demand. And in history, many sicknesses were spread because of the ineffective purification techniques that were available. And so this just shows the importance of water purification in order to safely reuse water. And I'll be going into more of these newer techniques within the last 100 years that have been able to safely purify water. So the two that I was speaking about in the presentation will be chemical treatments and membrane distillation. And you can see the chemical being added to the water on the left, and then on the right you'll see the industrial sized membrane distillation units, and also the science behind the pure water molecules moving across the membrane into the distillates flow. So first, to talk about chemical treatment, this treatment is achieved through chemical reactions. I was talking about two specific chemical treatment examples. Firstly, chlorination. Chlorination is the most frequently used chemical treatment, and it's the process of adding chlorine to disinfect water. As can be seen in the graph to the left, chlorination has had a significant decrease, has caused a significant decrease in outbreaks caused by waterborne diseases since its introduction. Today, in more recent years, there have been investigations concerning the possible harmful byproducts caused by chlorination, but because of how well it's been able to decrease outbreaks and disease and the spread of diseases, there is no sign that chlorination will be removed from the chemical treatment anytime soon. Another chemical treatment is coagulation. This can be seen on the image to the left. It's a process where a coagulant is added to separate a dissolved material that's in the water. Usually this is used to capture organic material, but current research also shows the possibility of capturing antibiotic resistant gene bacteria. Following the coagulation, sedimentation sedimentation period is used to actually remove the solid from the liquid. Next, I will talk a little bit about membrane distillation. So this purification method is driven by a vapor pressure or a temperature gradient. So this technique can be high in cost for especially for like desalinating water, because that is known to be a lot more difficult than most water treatments. Specifically, this newer technology that is being researched, which is nanophotonics enabled solar membrane distillation, locally heats the feed water with solar energy, which could significantly decrease the energy cost needed for the desalination, and make this option more viable for this purpose. In summary, there have been significant improvements in water purification, especially through chemical engineering techniques over the last 100 years, but today there are still over 1 billion people lacking access to clean water. So, with continued research and development, I think that, through this, like for example with the nanophotonics enabled solar membrane distillation, the decrease in costs can make everyone have access to clean water. And here are references.